Today is the fifth class of this 10 series, and I'm finishing the first semester classes. Others will come that will be given by the teachers and that will be related to the project that you are carrying out and have more to do with what you're working on. As you have seen, I believe that in these five classes, these five past classes, which will have the continuation with five others in the second semester, well, these classes try to talk about project theory and at the same time about experience. That is, not only explaining experience from an empirical point of view, which, as I said to you one day, is the way how you can acquire a certain theoretical corpus in project practice, but there's something which comes before that, and I mean sources. As Gaulenti said, who passed away a few days ago, she was a wonderful architect. I remember one day in Geneva, on occasion of a conversation, I was in Pauso, we were with Schumi and some other architect, and somebody came up with the idea that I invented something about the project, and she said, no, nothing is invented, some things are transformed. We don't invent, we do transform something that we knew before through sources. As you have seen, all the classes include the sources in which we might find part of the analysis and the reflection then ends up impregnating the whole projectual process. If the first talked about not so much imagination, I would say rather about an ideological position regarding architecture and regarding life, but also regarding the project. A project, I believe, has to be stained or colored in some way or another by an ideology. Oriol Bohigas already said that administration has to be ideologized, otherwise it's not a good administration. In the second class, the city was the main character as a backdrop for intervention, that is, landscape and the city as the backdrop for intervention in architecture. The third was about typology and social organization of projects, because this is a very important, programs are very important, which is what links us to the final object of what we do, the final user. The fourth class was about geometric instrumentation and the sources and the foundations, where in the 20th century we can find reference points to base our work upon in a more flexible and with more flexible and open geometries that enable us to work with more easiness on the project. And the fifth is about construction, which is today's class. Today we will talk about construction, thicker than paper. I believe that the name already gives you a good clue about what the class will try to do today. If we were to define a project as the distance between an initial idea and the constructed reality, that is, the project, well, then, the small thesis of this class is that the constructive mechanisms that make the initial idea formalization possible have to be inherent or implicit from the first phases of the project and the idea. That is, what I advocate is that it's not so much about coming up with a shape and then let's see how we build it, which is very fashionable in many of the architectures in the last few years, mainly. And interestingly, in the past, historically, it didn't happen. So the project was always at the same time as the construction. those constructive mechanisms have to be generated in the beginnings of what we can call the hidden part of the project. Well, there are two dimensions. There is the large dimension, the big plan, where the dimension in which the construction acquires certain specific features that has to do with size, with dimension, and with the scope of the project, and others that have more to do with the small dimension, which I'm going to leave to the second part of the course. In that larger dimension, those mechanisms, those larger mechanisms, structure, in my opinion, is the most relevant element. So today we're going to talk about construction, but also about structure. Why? Because structure, understood as the spatial support of the project, more beyond the physical support. It's not by coincidence that Álvaro Siza was a professor and held a chair on construction, and he always has said it. He says, I don't know what I would explain about projects. I can tell you about how I build. And teaching how I build, maybe you can learn. It's not because I teach it, but maybe somebody can learn how to project, because you project building, you build projecting. I remember when I was taking the test for being a full-fledged professor, and one of the tests was about giving a class, and I came up with the idea of giving a class on construction. I didn't have much experience, and I did the class however I could on construction, and the chairman of the jury, Oriol Boigas, and also Javier Carvajal, it was a very important, very relevant jury. One of the members protested, none of these two, but who said, well, you have given a class of construction in actually a class that was supposed to be about projects. And I thought, well, maybe, I don't know. But before I could defend myself, Oriol Boigas talked to Carvajal and said, no, it's really good. It's really good that professors on projects teach construction, because in this school, remember, it is a long time ago, there are two solutions, that project professors learn to build, or that construction professors learn to project. And I think it's much, the first is much easier, he says. And of course, that fortunately changed over time, and today we have great professors on construction. I believe that we have the best professor on construction, not only in this school, but I think in the whole of the country, and even more than, Ignacio Aparicio, who is a professor with whom I've been fortunate to collaborate, not so much on project, but all kinds of other things, but the project was also on the foundation of the collaboration, and he has this ability to be abstract and figurative at the same time. He knows how to figuratively build the constructive detail, but at the same time, he is able to abstract it until it becomes the foundation of the motif, the leitmotif, or the project moment. And I believe that is extraordinary. How do we begin this class? Why don't we start talking about trusses? Why? Because the portico, which is what you are taught in structures, well, those two triangles and a beam, and then the course on structures starts. While the truss and the two pillars, a portico would be like the paradigm or the simplifier of what a structure is all about. If we are to talk, if we are to start talking about trusses, then you choose what helped you in learning about trusses. In this case, the Maravillas gym and the truss projected by Alejandro de la Sota. In another class, we talked about power as an architect. Well, we're going to see that also in other classes. Well, the floor plan is also important for the architect, but With this truss, remember, between the initial idea and the constructed, the built reality, there is a long way, but the initial idea already contains not all the aspects, not only of the program, because this is the program, it's about covering a sports pavilion, and it's building the inner part of the truss, some classrooms, which is covering another upper floor plan, which might be another sports area, which giving access to light. Well, this drawing already contains everything the project is meant to be, which is a drawing, but also a structural and constructive plan. If the initial idea, as I said, already contains the essence of the final constructed reality, I think that that perhaps is one of the ways that I'm going to try and explain myself today. The first encounter with a public building was with a small sports pavilion, something as simple as covering a basketball or handball court. In Mongri mountain, at the foot of the Mongri mountain, the sacred mountain of the bishop, and it was a contest, one of the first contests in democracy, where small public buildings were built for cities and towns and villages in Catalonia, which were not profitable at all. We decided together with Arcadi Pla and Geroni Bonet to go to that contest, and I was a great fan, a great advocate of how Arcadi Pla already thought about architecture and went about architecture always from the point of view of construction, as he says. As I was saying, it was about covering a court, a basketball court. Well, and we said, oh, Arkady always said, you have to erase because you create ideas, and it's about erasing, to erase everything that is in excess, everything that's ancillary, and just to remain with the essence. The project evolved over time. The project was very simple, as you can see, just 2 dressing rooms, the toilets, and covering the court. If you see, if you look at it, there are some columns with lights between trusses, which will cover the upper part of the court, and with these walls, a small building is built with a small on the slope, which is slightly drowned in a depression. This is the exit hallway with this small slope, then these small stairways that cover this 1.5 meters, and then go to the court. And the beginning of this, all the trusses in the beginning and the end, there is no truss. Actually, the truss is replaced by pillars at the same distance that the intercolumns and as the rest. So the assessment, effort, and result is very apparent here. Where is the constructive problem? The constructive problem, as I was saying, as the competence always says, well, this is a problem. The problem is always in the corner. When you build table, and when you get to the corner is when things start getting complicated. Well, where is the problem in this case? In the last truss. Why? Because the last truss doesn't fit actually with the others, which are very well balanced. The last truss has a tension which is not appropriate. So, dealing with this constructive situation in a special way, I think this was the reason for this very small, almost insignificant structure calculation. Imagine this is not much. And then we made some detailed drawings and look at these circles to explain where the section points are going to be, which can make for this corner problem, with this constructive conflict. How do you build bleachers, well, strip footings in a place where it's all rock? Obvious, isn't it? Where would it be in these drawings in the upper end? Well, you have almost a flat cover, a flat roof. We didn't want a two-wing roof. We wanted a flat roof, and which could include a horizontal and flat court. And where is the constructive emphasis placed? In the watering tubes. We wanted pillars that were square tubes in steel and hollow. We generated a mechanism for the water pipe in the inner pillar, and so you can remove water in many points of the roof, and then you have a square centimeter of the roof, square meter of the roof, and then a square centimeter of the water tube, this is what was very difficult with us with a flat roof, to remove rainwater. You see the intercolumns, you see the trusses, how the bleachers have become a stairway that provides access to the bleachers and then ends up disappearing. Then the ventilation, the airing of the clean feet hallway, and also a small gate with light for the lower part. The thing was about creating a very clear and transparent a box. This small building, which is very simple, as I said, was not that simple after all, because Avalos Herreros, before they built their sports pavilion, came 3 times to visit it, to look at it, and they didn't come to see the architecture. They came to see how to build with less material, which is what they always have been interested in, particularly in the first few years. This small pavilion, look at how the columns, the pillars continue, and then we have these 4 intermediate columns with plus the 2 ends, and they replace at the same pace, in the same rhythm, the last truss with pillars, and that was very praised by Ignacio Aparicio. He even names it and mentions it in some of his books. Some years later, with José Luis Canosa, we won a contest to build the La Mella Sports Pavilion. It's a larger structure with more dressing rooms. The court was also larger, and covering the bleachers would be more complex than before, because the bleachers were not within the box of the court itself, and that gave us a clue, because we thought that at that time that the larger the structure, the more iron we would need, which was a very simplistic transposition of structure calculation. But what you can see here, the section and the floor plan, and how we try to solve the whole structural problem, and at the same the light issue, through a single element, which is a large truss of 50 meters of light, almost 5 meters on the side. And this truss, in order to stabilize it, first of all, it will receive the weight of the half of the roof, but on the other side, how is it compensated? Well, you tension, you tether these small those trusses with cables. In this way, the truss is stabilized horizontally and also vertically, because it is supported by 2 large concrete pillars that are built and on which the trusses penetrate with neoprene supports, and that makes it very simple. It's not reset, and it can be very flexible for growth, dilation, and so on, and expansion. Well, interesting about that is that the truss was calculated by Agustino Viols and Luis Moya, and obviously the truss was well calculated, but in order to execute it, and this is what the class is going to explain as well, we had a very specific problem, a very specific issue, and that is that 50 meters of truss that came in parts on a truck and they were welded on the construction site, that weldings were verified with X-ray and also penetrating liquids and so on. It had to go to it had to be transported up, and we needed two large synchronized cranes in order to place it there. Something went wrong. The cranes did not work in synchronicity, and when they were taking it up, all of a sudden the cranes lost the truss line, and at that moment the truss became a moving part, a very dangerously moving part, and looking at the face of Luis Moya, who was assisting the operation, was actually horrible. Down, 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 they said. The truss didn't break, it came down, but wow, horrible, what do we do now? So he did take some measures, and then the operation was repeated a few weeks afterwards. It was placed perfectly with synchronized cranes, and there was no more problem about that. Sometimes you don't have only to think about a structural solution, but how you execute it as well. I remember a professor who said, the architects have to pay attention to those who are going to build what we draw, and we have to be very respectful with them. We cannot be megalomaniacs and provoke suffering in building for those who are responsible for building. Well, at the end we had this box with plain concrete pillars, very clean, very simple. And about trusses, and I finish with that, because I think I could have talked more about trusses, but I think that it's enough talking about these examples. Well, this project was a contact with Octavi, and what we did was to build kind of a museum where the different rooms go down are buried in the ground in Galicia, and at the end of the whole path, at the trajectory, there is a ramp that takes you back to the point, to the starting point, going through all the boxes. We didn't win that contest, but I believe that we did learn something which is very useful. And today, then it is that today, because of calculation systems that are linked to numerical control machines in order to carry out the oxycut of the beams and the pillars, we were able to build this structure with all the trusses that end up developing the whole project. Each truss is slightly different from the previous one because of the roof curve, the load, the dimension, and so on and so forth. Today, it doesn't matter if you make them the same or different, because with the numerical control machines, you enter the drawing of the truss, and the steel plates are cut to the respective shape. So the industrial process, which would have been absolutely horrible a few years ago, is something now completely normal. The result was this one. And I finished this small section on trusses with a curiosity. This is a truss which is called fly wing, actually. The engineer who came up with it and built it was Joan Torres y Guardiola. He was called the Catalan Eiffel. Maybe you know him because of the scaffolding that he made for the Colón monument. He is it's very famous, and it's in very many books, an incredible scaffold in order to build that monument. He also has architectural buildings because he was an engineer and also an architect. And then he was linked to the steelworks Torras, which is where I found the drawings for this truss. When we demolished the steelworks Torras factory, I'm very interested, and I showed it to José María Montaner. He researched the archives and he found something very interesting. But it is a wonderful truss because it minimizes the weight of the iron by 30%. So the same light as in any other truss, but with 30% less iron. And look, it's frankly interesting and beautiful. And we used it in a small building, in a small local market that we made the beam, it was calculated, and so on. And this engineer, well, he devoted his life. Since today I'm going to talk about engineers a great deal, I would like to start with one who is very close to us here at home. Today, now what I'm going to do is I'm going to try and explain the architecture or the project as the mounting process. How can you understand architecture as a project? At the same time, it can be like building a meccano or like fragmenting a project or breaking it down in those complex or not so complex parts that you put together, and then you end up building the skeleton and, after all, the building itself. Maybe one of the first people who studied buildings in that way, breaking them down in that way, was Auguste de Choisy in 1873. Why? Because Auguste de Choisy, he x-rayed and he exploded with axonometries and isonometries a large corpus of monuments of classic ancient times, Roman, Greek, and Byzantine buildings or structures, and it's really a great class, a master class on construction. For me, one of the most important architects, in my opinion, is Louis Kahn. He studied Choisy, and he spent years studying those axonometries and understanding how they built. And if we think about Louis, we think about many examples, most projects by Louis Kahn, we can see this way of projecting and building, which is what we call the Kenyan architecture. For me, the best building by Kahn is the one in which this story, this idea is slightly hidden, which is the Kimball. Because the Kimball, we read it, we interpret it as vaults, but they're actually false vaults. They are cranes, beams that are disconnected, because through the center of that false vault, light comes in, utilities go through, and he builds what for me is an absolutely magical building. Look at the model and how it tries to reconstruct the idea of the project from the section, from this drawing, from the first three drawings up to the construction, the final construction. You end up with this, which is marvelous because it's the cross-section or as the sublimation of the architectural idea. Light, space, function, materiality. Everything is there. The Kimball is the ideological expression of the architect. From a much more humble position, with Alberto Peñín, we tried for years to rebuild, to reconstruct that idea, to recreate that idea. And the first time that we faced a building that we wanted to understand as the expression of these elements or this puzzle was the Congress Palace, because the buildings did not have many possibilities. It only had 9 meters in height, and you you couldn't build more on the diagonal avenue, but the interior is much more powerful. And it's the first time that we decided to work with white concrete, because the backdrop was somewhat of a challenge. Well, white concrete had very bad press because it was said to have less strength, less resistance, that it was impossible to repair, that it was very difficult to build with it, and thirdly, that it was very expensive. Well, it was not true at all. White concrete is high strength if you know how to calculate it and to dose it. It is even easier than repair than gray concrete, which for me is almost impossible to repair. You can sand and veiling it. You can sand it with two zeros, and then you can veil it, which maintains the appearance of the concrete, but which actually has all the other advantages of other kinds of concrete. But with white concrete, that doesn't happen. It's easy to repair, and it's not more expensive because it provides a finish that is not provided by the gray concrete, which you have to finish on top of building it. Well, in the drawings, we already tried to express this idea of how to create or mount or assemble the building piece by piece. And even the models in which the relationship of tympani and planes, which is going to build up the whole story of this section. Some sections would contain different functions and dining rooms and meeting rooms and auditoriums and offices and halls and so on and so forth. And how do you make justice to the idea of the project? Well, you build the tympanums and the slabs, the tiles. You have to really study very in depth the connections, how you're going to connect the wall and the tiles or the slabs. And then you create a structure, which is when we met Juan Calvo, the engineer, that Ferrovial, the construction company, the company that we called to help us, because we did not want to use columns. We wanted to project and build with the same simplicity and very much considering materials. We needed a genius in the placement of building works. Orellano, it was. Well, without him, it would not have been possible. It was his last project. He retired after that. He studied of how to do the form work and how to study them. With Alberto, we cheated a little bit. We created a construction module with form works, which was not standard, and we needed to build, and of course it was cost-effective, to build. We decided to build metal formworks very specific for this building. And thanks to Aureliano and thanks to the building team, it was splendid. It is a result of a good assembling. Look at the panels, the position of the panels, and how their beams will be placed after preparing them inside of the pilasters, and how the concrete tympanums were placed, and how the complete simplicity and neatness of this meccano and the axonometry, which really explains very well what we wanted to do, how the beams were placed, the different layers, the isolating layers, the carpentry, and so on. And all those utilities were pre-set up and then within the walls and within the slab. So we needed this covers within the formworks for air conditioning ducts, for utilities, for cabling. Look at these tympanums that were very loose, extraordinarily 18 up to 20 centimeters max, and how this large tympani that we can see as large lintels below that there are wooden boxes. Those tympani, they act as large beams, and they are more than lintels. They do not act as lintels because in some cases they are 50 to 60 meters long, but they act as the final support of a cross-sectional system of tympani that is balanced somewhere else. That is, in this building, we have post-tension cables in some areas, but in other areas we have counterweighted cables. That is, the loggias of the auditorium counterweight the effort of the hall, and so on and so forth. This is the result. Something similar we try to do in Castellón, and the idea of the assembling is much more apparent here. Because look at how the building is created. Well, it's beautiful in a construction site, because usually I have gone to many construction sites in my life, and you don't understand anything when you see a construction site. How is it going to work? No. It's not bad in the construction process. Something is not possible. And I'm going to say something contradictory in another part of the class. But I think that it's good to see the whole process in fine-tuning. Of course, a very opaque, closed down, a very tectonic building in white concrete. Well, it's, after all, only an outer casing that is then around a road or around an expressway. And look at the isometries or the axonometries of Juan Antonio Rodriguez are extraordinary, because they perfectly explain, they x-ray beautifully all the points that are going to be interesting for the construction. If there is a mistake, it will already be detected here. That is, building will be about transcribing the drawings, although these drawings will have some thickness, some relief. At the end of the day, the interior is full of light. Look at how the section reveals that the building flies over the ground. So you go into the ramp under the concert hall to reach what we call the central lobby, and then you go down to the foyer, which is nothing else. Well, we talked about the foyer, which is the bellowing, and the foyer, the French word, which is only nothing else than the transcription of the lower part of the auditorium, which under that is constructed with these pillars and these concrete beams towards this large lintel that with the support and provides access to light all over the building. So the building is drowned in light, even though the exterior might seem very opaque and very tectonic. In this case, sometimes that I have already explained that things are not what they seem. This is a building in Montjuic, close to the botanical garden. It seems to be supported in cantilevers, well, large cantilevers. When you go under the building, you say, wow, these are very pronounced cantilevers, but it's not true. And then you can see it on the site, at the site, because what they do, they use this receptacle, which is there in the lower herbarium, which is a concrete box that contains all the whole herbarium of Barcelona in ideal humidity and temperature conditions. And then you can launch these large porticos or pillars with trusses which support the cantilevers, the tiles, the slabs of the cantilever. In some cases they don't appear, and then they do appear. The section is very different. It's cross-sectional in this building, and it's always the same. Structurally, it's always the same, but it does allow for continuous variations when you think about a structural mechanism in such a way that it's sufficiently flexible to leave some holes or gaps where they are needed. You can see the axonometry once again here, in which the inner space allows for light to enter, and that changes the program, the labs, working areas, offices, library. It changes, but always maintaining the same structural section. This is, without changing the structural system, you can change the inner space and the access of light to light depending on the area where you are. And then, what we said at the beginning, which is the large dimension. What happens when a building surpasses what you have imagined and has 200,000 square meters and is 1 kilometer long? Well, in this case, I think that mechanisms are similar, but they do have some difference. When you have a large dimension, there is repetition, you have modulation and mechanisms at a different scale, which I will talk about later when I talk about engineers. They make a different sense. When you change a scale with such a strong change of scale, you have to do an exercise. The first drawing of this building, without knowing anything, you can start to understand what might happen. What happens? What do you do when there is a great effort? You turn it around, because this drawing first was the other way around, and then you have a catenary, the catenary for all the cables of all the bridges, of all the cable sails and the bridge, and we turn it around, and it is the structural drawing for any kind of bridge with two pillars. I think the intention, when you dislocate because of the situation in the landscape and the arrival of the railways and the platforms and the roof of the whole building, then you have a mesh vertically and horizontally, which is when we contacted Juan Calvo, and our engineers were very important, because the railway company did not trust us. The project was the responsibility of engineers, and architects are not important in such infrastructures, only for technical assistance when you are building an airport. But with Ramon, we know that very well. What is the architect? Well, Zaragoza was about to collapse because engineers did not believe in this idea. They did want the largest, the greatest station for the 21st century. The contest had been won by us for a very small detail that made it more attractive, with halls, the arrivals halls, the departures halls, like an airport. But the position of Barcelona, which has a centrally located, such in Barcelona, Madrid, and Bilbao, and Madrid, and other major cities in Spain are very close to it. It had to be like a clockwork, a very accurate clockwork. So somebody that came from the regional or the private car or the bus to the station, then they had come. They had to be placed in a high-speed train in 1.5 minutes, because otherwise it wouldn't make any sense to make such a great effort. The structural issue is that the roof is very complex, because first you have a mesh, then you have these tetrahedrons that have this lighting function and acoustic function, but they are like Vierendeel beams, that is, immense Vierendeel beams that are all connected. And at the same time, you have the device that is, when you turn the drawing around, the arch, because it's a diagonal arch. why are you trying to bridge a lumen that is 100, 140, 150 meters long and diagonally? Well, we did because the structural mechanism, after it was placed, after it was checked by engineers, they all said that the amount of iron would be the same with a slanted or with a straight solution. And because we had the arches, we had the Virindale beams and the mesh, we could build a structure which was absolutely stable, which would be then safe and sound from wind and other problems. When the monster, and then the construction of the roof. Look at this beautiful picture to the left and how it is built. It's very light, so we are covering 40,000 square meters, the equivalent of 8 football stadiums, without any pillars. Look at the secret of the mesh. Look at the upper picture, which is very intricate, and now you can see the order, the Virindale beams, the tetrahedrons, and the large arches that Juan Calvo defined as 9 consecutive bridges. It was like a bridge structure. Look at the knot and the size of the knot. The square tubes that make up the tubes of the arch was the traction stays had to be verifiable inside in order to check the welding, so a person could go through them. So we came up with a way of doing it on the ground, a perfect way. So we created openings so that you could go in and out, small areas that then could be closed to check them. And the station is a set of buildings which surround this area, office buildings, hotels, all kinds of types with different programs and purposes. And look at the section. Yes, on this side, the support is particularly on the mass of the buildings that we have seen in the previous picture. But on this other side, we wanted to empty this, because we could not make it any longer. We had the building, it was very close, we had sufficient platforms, we had the buses, we had everything assembled, we had the south parking area, the north parking area. So we built, as you see, this invention, which is why we won the contest. This is what we call the transfer, which is a device that means that from the parking areas, from the bus station, from the regional train station, with remotely controlled doors, you could reach the high-speed train in 1 minute. You leave your car, you walk, you have your ticket, you are in the high-speed train. You don't have to go to the hall, you don't have to waste any more time. And that goes under the tracks, and it also has daylight because you have ramps with some carts. If you want to go to the platforms, if you want to go to the ramps, you can do it, and always with daylight. But the structural secret of the whole station is here, because this is what we call a double facade. This is in construction here. These are two very fine concrete timpani where Juan Calvo created a support system. This, I think that even 4 or 5 structure professors went to came to Zaragoza to check the invention, because they didn't trust us. Because we needed to empty this tunnel, because the transfer connection is the connection between the arrivals and departure halls that are east and west. Also the longitudinal connection with all the different comings and goings of the station. If you have people coming to pick you up, they go around here, which is the non-secure area, and also connects the transfer and the parking areas downstairs, which is the mechanism that makes it all possible. This is why the station only had a hall in the beginning, and it didn't work until it was already in place. You have the drawing of the roof here, and at the end, this roof that seems a floating roof with large triangles, little birds of 900 square meters each, and finally, the view. It's now time to talk a little bit about walls, about large walls. I've always been fascinated by the construction of silos, because they build concrete silos at an incredible speed. They use formwork all over the place. They use concrete with hydraulic jacks that transport the concrete, with sliding concrete, not with climbing concrete. And if you can build silos, and they do it in such an incredible way, you can see the lights at night. That was the idea. Well, I told you in a class that it was the first idea for the hotel, etc. Well, today we're not going to talk about the projects, but about the mechanisms that made those projects possible. And then I asked, if you can slide a silo, a cylinder, could you not do the same with a wall? If the wall has a certain thickness, well, it's never been done. But in the end, a Swiss engineer who had slid very many things in his life said he would be able to do it. He came to Barcelona and he did slide the walls, those huge screens of 80 meters of the hotels in concrete, sliding with hydraulic jacks, 12 days, 12 nights for each. And I remember the comments from Giuseppe, "Well, you are crazy, you have gone crazy." And I said, well, yeah, behind this there will be a hotel. And I thought, well, I wish I could do this with these huge sliding walls, but the fact of being able to build those hollow walls inside with their own infrastructure, the lifts, utilities, machines, ventilation, is what makes for this very clear and transparent inner space with these polygonal walls with the formworks, in order to create this, we transcribe this idea of the door, of the scale, not interpreting the scale of the building, and in the same way as we would the rooms of a hotel. And the second part of my class will be about engineering and architecture. Why? Because I want something that I want to advocate that it's very important. I have defended, I have said that constructive mechanisms and structural mechanisms have to be there from the beginning. Obviously, architects, even though we have studied integral calculus, which we did, and many other things about structures, we don't have the ability or the skills that engineer has. So I think that the engineer is very important, and we don't have to wait to call him to solve the problems that we have created previously. We want engineers from the beginning. In a very beautiful paper in Palimpsesto journal, Juan Miguel Hernández de León talks about the relationship between engineering and architecture, and he talks about the 15th century. Filippo Brunelleschi and Leon Battista Alberti. One was a great builder, a great engineer, the other was an intellectual, an architect, and how that transposition, that relationship between the first architects and the first modern engineers in history is very present. You have that article, and it will be very useful for you. But let's talk about two very interesting contradictory cases which seem to absolutely collapse the thesis of my class. Alberto Peñín has written his doctoral thesis about two buildings, the Sydney Opera and the Pompidou building in Paris. So, what's going on here? It happens that Piano won a contest with a wonderful, absolutely wonderful project that you can see here. and it has been the icon of icons. That is, in this case, it has represented a city, a continent, a country, a nation, and a continent. And it's represented by this building. The Guggenheim wanted to do something similar. There are very few buildings in the world that have really achieved that. But it's not the right time to talk about that. But when Utzon made these wonderful, these beautiful drawings, these shells on the landscape of Sydney and the water and the sea and the harbor, he doesn't understand that he has a problem, and that it is the impossibility of combining intuition and roof geometry, and how you're going to build that. The thing is that after the contest was won, when Ove Arup came to save the day, to help them to see how this could be built, this impossible structure, qualified engineers such as Nervi Candela criticized the project by Utzon because they say it's not buildable as he had imagined it. The roofs have an inappropriate curve, radius, the curves, the point supports, make them completely unfeasible. There is a young engineer, Peter Reis, who is working with Ove Arup, believes in it, and one day after 80 tests and 80 structural proposals from Ove Arup to Utzon that it didn't accept because they distort the initial idea, finally somebody came up with the idea of a ball. If those segments were part of a spheric geometry with the same curve radio, the thing might work, the whole thing might work. And evidently it was like that. They cut a ball and they started working, and Peter Reis started to work. Who draws in descriptive geometry all the segments of that ball and of the spheres? Somebody who you know very well, Rafael Moneo. Rafael Moneo worked with Utzon, and thanks to what I said on the class on the geometry, that descriptive geometry was very important at school. In this school, his knowledge about descriptive geometry helped him achieve the execution of these shells. Moneo draws them, Peter Reis builds them, and we had post tensions and very complex techniques to build the idea, and finally the building was built. And something similar happens at the Pompidou. And Penin's doctoral thesis is very well explained. You see a whole combination of things. You see a bridge. We're talking about 1867. Sébastien Gervais invented a system called La Gerbreite, which optimizes structural efforts on a bridge with a moment, diagram of moments, and look at the diagram of moments. Something that Ms. van der Rohe also does when in the new gallery, well, when the structure is mounted, why do the corner pillars disappear? Because they arrive generating cantilevers that compensate the flexor moment of the maximal light, and Mies also includes the hyperstatic knot that is heme, welds and solidifies the knot in a way that the diagram of moments also is optimized when you lower the moment onto the support. This is very beautiful, and this is a beautiful story of cast iron, because Piano and Rogers want the building to be of historical nature. It's in Paris, Baltard, Les Halles, a whole story, a tradition in the construction of markets with cast iron, with metal structures. And they also believe that the pieces, the cast iron pieces, go above what is the large size of the building, and also pay attention to small pieces, which is very well in fitting with their ideology. Peter Reis, a mature Peter Reis, He turned into a genius of structures, so much so that Piano, at a certain point in time, says that building, like in Sydney, well, it's a very good, solid, sound building. It wouldn't have been possible without the work of Peter Reis, the engineer. Well, this is the danger of contests. Contests value an idea, but ideas are very quick. There's no time to settle them down, to make room for these constructive mechanisms that I mentioned at the beginning. And then you have to bring them later, and you have to readapt the project completely. You have to reproject it, as Utzon said, over decades, but not so many decades. Maybe it was easy here, but they had to do this. And then you can see the building turned into an assembly of metal pieces. The pieces are assembled, cast iron pieces, other pieces, and then you use the Lagerpret system, and you have the wonderful building of Beaubourg, which is one of the greatest buildings of modernity or contemporary times. If we continue with this story, well, Louis Kahn, of course, Louis Kahn would be very difficult to understand if we don't speak about Commandant. Commandant is the engineer who builds the Louis Kahn's architecture and who builds with him. All these engineers at certain points in time were complaining a little bit. Yes, we'll see that it is so, that there are sometimes complaints about or against the architect, but well, Kahn Commandant are a great team, and one of the creations look at the idea of assembling, the idea of roof, the diagonal structure, the empty timpani, generating light, purpose. Other examples, I have only a few. The other day I talked about Cécile Balmont in London, and also Foster, for example, who talked to Arup, and worked with Arup, but also with Michel Virloger in the extraordinary Bridge of Millau. One of my favorite works by Foster, and I went to see it the other day, was Stansted, the airport. Because this tells us where do you get rid of water, because these tubes do not allow the passage of water. And I started looking for it, and it doesn't happen. It doesn't happen. And we're talking about an immense flat roof, and when it snows, but I looked and looked and looked, and no, we didn't find how they get rid of water. And I also thought that they even had some heating on the roof to evaporate the water. But when it reaches the facade, the carpentry, a little bit like in Torroella de Montgrí, small, minimal tubes, but very many of them that get rid of the water with Jevary systems, and with a Venturi effect, the water circulates at a much higher speed. It is a Swiss invention by a Swiss who was called Jevary. And once I solved the riddle, I was more reassured when I was looking at the building. I think that Foster is probably the architect who has best been able to work with engineers, who has best understood what I will call what I would quote by another very famous engineer. He has understood that construction has to be at the essence of the idea, and this is what happens with many of Foster's projects. In some, it's not. And then the buildings are a completely different thing. Let's now talk to our best engineer, Javier Manterola. You also have an article by him, or an interview with him in issue 5 of Palimpsesto, a wonderful interview by Peñín. He starts with Carlos Fernández Casado, one of our best historical engineers. He is still working, although he has reached an age where he can work independently. Don Javier Manterola, you can see his bridges, the best, the most incredible bridges. And he has worked with many architects, with Moneo, Oiza, Corrales, Molezún, Higueras. And I quote too, Oiza and Moneo. Torres Blancas was a great work that Manterola said he learned so much about the architect and about his great stubbornness. I mean, Mr. Oiza. And he also worked on the Kursaal with Moneo and also many others. I use the Kursaal, well, because Moneo, the structure, the boxes is more spectacular. What does Manterola say which is necessary to have a collaboration between engineer and architect? Well, the building has to be at the essence of any thought, of both. And he complains a little bit that architects with whom he has worked, well, because at the end of the day, they always wanted to impose their own criteria, and I don't like that. This is why I left that behind and I started building bridges, where he is the boss, and also they are of a different structural dimension, because architects always dream about building bridges. Well, I believe that with this, well, I gave another example, which is personal, of cooperation with a great engineering office, Arab Sports, who built the arena stadium of the Bayern, and also the nest in Peking, of course, although I don't think it's that beautiful. And we went with a team with Vives and Serra, professors of this school, Luis Vives, Santi Vives, and also with Borja and some young architects. By the way, they came to work when we were working on the contest with Barça shirt, with Puyol and Xavi to really get in the mood. And it was a great cooperation because Arabs engineers came to Barcelona, we went to London, we had a team working with them, and they came up with this roof and also the maximum view line, removing the third bleaching because it was obsolete, it was not well built for the Football World Championship, and it's not according to UEFA rules, and then in slopes and in construction. And we replace the third by this other line of maximum view, so that you can goes down in the corner areas, and in order goes up in the goals, so you have the best possible angle and visibility. And you have a very complex story here of with this plated kind of cover of roof. And then I'm going to finish with 3 examples, construction examples. If I didn't walk the talk, you would say, well, what about you? Yeah, me too. I always try, and we all try, the people that work at OEB, we always have understood what it is to work with an engineer. And that engineer has always been Juan Calvo, who appeared in that conference palace to bring some order, who has been in Zaragoza and has been on all of our latest building projects. And I'm here with Juan in Chicago. Before going to Chicago, he was a great engineer, and now he's also a good friend. And it was another good cooperation between architect and engineer. And I know the auditorium building very well, and I had to write a video that I was commissioned by the Architecture's Foundation. And the vision, or Albert's vision, together with Sullivan, was absolute, not only structurally but also acoustically. In here, the marriage of architect and engineer was absolutely wonderful. Let's come to this picture here. We cannot see this picture anymore, unfortunately. the Twin Towers by Yamasaki. I had been in the building twice. I had been upstairs. And the first thing that you do when you, in those cases, in the Empire States, well, you go up in the lift and look at the views. You had also the skylines drawn on the windows in white. It's where you could see everything. But the most interesting thing was not to look at the tower from upstairs, but from downstairs, because this is the interesting story, this calculated story with finite elements, and the facade itself is structural. So much so that you remember when, in September 11th, when the planes collided against the building at 500 kilometers per hour, thousands and thousands of tons launched at terrible speed against the towers. There was a huge haul, but the towers didn't move. You have seen it on the video. Then they burned down. That's a different story. But the structure holds. And why does it hold? Because of its solidarity. And this is the foundation for the idea that I told you about from the point of view of the geometry. But I'm going to tell you about the point of view of construction. When with Xavi Martí we started to look at this, I called Juan Calvo right away, and he always comes running from Madrid, or either on the plane or on the train, and we started looking at this facade being the structure, because we have spaces of 16, 70 meters that can be completely saved with post-tensional cables of 30 centimeters in diameter. And we also were able to deal with Bolivia Street, which has a very similar space. The combination of slabs and a post-tensioned facade and this mesh structure in the exterior, and it allowed us to remove all the pillars, and you don't need a 7.5 meter pillar, which is really annoying. Everything was worked upon, and look at the diagram, the drawing by Juan Calvo. I'm going to repeat it because it's very short, very brief. Look at the most loaded areas that are most burdened, and the diagram, the building, is then balanced until everything is in blue and everything works in the same direction and simultaneously. That means that the calculus system with finite elements allow us to work on very complex structures, more so than what you were able to do only a few years ago. Explained by Juan. What you do is you distribute the exiles, and there is, well, the system is then well balanced. There is a certain structural democracy which allows us to stabilize the whole thing and to turn the structure into a system. The pillars, as you can see, they came in blocks of 2-3 stories. You see the nuts prepared here, and you see the structural organization of the building. And you can see how one of these pillars has an inner armoring, which will be then filled with concrete, with a special, more fluid concrete, and which will provide the pillar with fire inertia that will enable us to avoid, protect it against fire with paint, which is going to be very good for the fire department. The fact that the mesh is 70 centimeters plus 30 centimeters of the slab is something that is very good to pass the test of the fire department. And actually, it passed the test with flying colors after Juan Calvo explained the whole thing about inertia and so on. And the secret also lies in, well, you can see here a knot being filled with this special concrete, and now the post-tensioned slabs that are easily executed, because once you pass the sheaths, that you can see on the upper right picture. Actually, we have two standard meshes. You don't need this specific iron mesh with reinforcing beams, with steps, and with legs that you have to fold, and with overlappings. No, it's just very clear meshes. You can see here the release of the last pillar and how it is, the whole system is built. Any pillar, all pillars are the same, but all are different at the same time. The steel plate thickness of the pillar depends on the location, 2, 3, 4, 5, 10, up to 15. And there is even completely solid pillar. The relationship between the initial idea and the constructed reality. Well, the process is carried out as a plot, like a red line. The constructive process is a plot, like a book or like a movie. There is a direct relationship between skeleton and final shape, and then the windows are placed and so on. And this picture very well explains the key, always the arc. The key is this pillar, which is the most burdened one, and then it's released, and the glass does not reach it. There are pillars that don't follow up or down, and this is what I told you at the beginning, because there's no direct translation between the shape that we see and the support, the structure, because it's not necessary anymore. And calculation systems and OxyCAD construction system, numerical control, allow which was more figurative is now more abstract. We look at this building and we don't necessarily understand how it works structurally. We don't see the inner side of each pillar, the position of each pillar in the mesh. There are things that follow us, cantilevers that seems randomly placed. Well, the random element, what seems random, it becomes the constructive logic, and I think that's very interesting. The second and next to last example is the shell of Benidorm. How do you build a shell? I told you the other day that this drawing was probably the most important in the project that we developed with Xavi Martín. He realized, and he made this drawing and realized that modulating this story, we not only had more geometrical simplicity, but that we could also find a leitmotif, a plot, a constructive alibi. And then the wise man came. We created the project with Juan Calvo, and it was very simple. A shell of 8-10 centimeters, randomly placed, chaotic forms that we had drawn with the cutter and all that. And because of the convexity or concavity, had a certain structural inertia that provided support for the plate. And some engineers from the Polytechnical University of Valencia came with an invention. And, well, they did not say anything to us, the architects. They went to the government, actually, and they sold the invention to them. And the invention was about, okay, what you're going to do in Benidorm, you have to build it in the following way. Formwork molds. You don't need a mesh. Why? Because we're going to use Tramax. Gramax are galvanized needles that knit, actually. And these galvanized needles provide strength. They join the whole concrete plate until it's stable, and you avoid the mesh because Gramax is blended when we blend the concrete. We get a call from the building, from the government, and they said that it's going to be changed. Xavi and I were very nervous. We called Calvo in Madrid, and Calvo said, well, they're crazy. Well, if you say, Juan, that they are crazy, well, that's it then. And we said, okay, before that, we want to make a test. We want a demonstration, a demo, as you can call it now. well, the demo. And we were a little, evil, and we thought about two formwork areas. They were not perfect, as you can see here, in order to carry out the test. We took these two sections. Well, the government came, Gramax and concrete, the government came, Xavi and I didn't go to the test, but we were in constant telephone contact with the building site manager. At 6 o'clock the next morning, both collapsed. Well, the invention had not worked. We went to the construction site, the government was outraged, we didn't see those Gramax guys anymore, and we used the mesh, we carried out the test, and it worked. Well, the problem is, well, we didn't like the Gramax because galvanized needles next to the sea, they reach the skin, the epidermis, but the mesh is at 6-7 centimeters depth, and it's also galvanized and stainless. The thing is that once you have decided, pouring the concrete, you have to project it. You don't have to vomit it. It's not like a swimming pool, and you have to project a more fluid layer, which is going to go against the formwork, and that has to have the mass. It has to be full of polypropylene fibers, because polypropylene does help to stabilize the small fissures of the plate. So the mesh is responsible for the structural inertia. It armors the shell, but the propylene fibers provide this minimal armor, and they don't rust. And of course, with Xavi and I created this system. We contacted a smart scaffolding house so that you can deal with any variables. And the result was, well, we did it in the traditional way with cables, with pillars, and well, our whole intelligence went to hell, and the building company showed that they could do it exactly the same way without having to support the whole thing. Look at the shell, 8 centimeters, the formwork, the supports, and how the sand was separated in order not to ruin it, the interior voiding, which is projected from behind. And now you see the system. This is the topographical study that has been done from the shell, with the shell, and what we call the eye of God because of its complexity. Because Juan said, this is the issue, this is the real problem. The corner that we said, the problem in the corner, this is the problem, because when you empty the system to generate the stairway that go down to the beach with this tunnels, up and down, upper and lower tunnels, that requires a technology, and you need a complex geometry and a technology. It's almost like a bridge, like a gangway, and you see this splendid geometry here, and how the hollow core slabs were placed, and then the issue of the molds. And we contacted a craftsman in Villena, a closed village. He's going to build the timber molds. Xavi took care of the whole process, and he went there with them because they created this these boat pieces, and it's boat construction, it's ship construction, shipbuilding technique, because at the beginning we had to have polyester molds, but then we had the slats and the ribs all in timber, and then we did the digital model, and you can see here the molds getting built, splendid. They will have more or less 4 elements each. It's like a sculpture, don't you think? And you see here the execution, wonderful. The most beautiful thing for an architect is when an idea becomes a reality. Nothing is better. It's much better even than the final picture. When you go to Zaragoza and so on, it's a wonderful moment for in the life of an architect. And I only took 3 pictures here, 3 drawings, the concrete, the slabs, the transition slabs. On the one hand, we have the V's, and it's a micropile system that was invented by Juan Calvo, very inexpensive, to protect the blocks and the buildings and the towers that are on the promenade and that are very poorly cemented. And so we generated this barrier with micropiles to stabilize, so that the cemented structure can never be moved. It didn't move at all, not a millimeter. And then the cemented structure of the ribs here, that from which the plate is going to hang, and these ribs are perforated, they have orifices, and then they have the exact section of the specific topography, these slabs that will build the topography of the pavement. And you can see here the construction, the slabs closing down, and how the details of the cantilevers for the shells are completed. Then the pavement, the reinforcement for the shell. You can see also pictures of the convex and concave structures and the mesh, the secret of the mesh. And the door, because the promenade is empty, so the back side you can visit it and supervise it through these small doors. And the great movement, the construction of the shells, in detail, the formwork, the mesh, the concrete, the little tension elements, also in the form of a mesh, because they are curved. They are left open because otherwise they would probably provide it with LED lights at some point, which would be very tacky. And then the construction of the pavement, which are not a finish, but a part which, because they guarantee the topography of the promenade and they follow the design of the piece. By Xavi, look at how marvelous it is, how the pavement is placed so that topographically you can deal with all situations without any other further details. And then another idea to finish with the project. The project is completely different, the sea, because this is wonderful. And I'm going to finish the class with this project. Well, somebody might say, if you're always talking about engineering, about the large dimension, why do you finish with a single-family house, a single-family home? Well, sometimes such a single-family home might also mean building in a large dimension. And I tried to explain how engineering and architecture allow us to convey our own construction systems or to the building of private homes, which is what we tried, and also many other architects have tried. In this case, this single home, a very large home of 1,500 square meters. Maybe in another class we will talk about that when we talk about inhabitants. But it is interesting because look, this drawing, that drawing, look, it's like an origami. It's something called, well, actually somebody called it the origami house. Well, if they want to call it that, it's okay with us. That drawing involves issues that have to do with the floor plan and also with the section through folding, but also have to do with the space and the volume. And the proof is that steel plate, steel sheet model which is exactly folds that diagram, that drawing. Then you have three layers, and we decided that we wanted to build a slab. The slab, which is going to be the isolation slab, and then the roof, and the slab will be seen from the inside, so the skeleton will be the final result of the inner side of the house. And that involves something else, how the breaking down of the idea in order to be able to build it. Slab, 22, 23, 24 centimeters. I think it's 23, 24 centimeters. Isolation, ceiling, the mesh that it covers, it, and the 6 millimeters of the finishing with a ceramic sheet. It's not even 30 centimeters, the thickness of the whole invention, but you have to break it down and then you have to build it geometrically. Juan Calvo, first structure expert, told us, well, I can build this in iron, but wow, iron, you will have this beam corners, but in 22 centimeters we want the whole shell. We already have built it and we want it to be seen, to be nude, and following the formwork. And Juan created a shell which was cos-tensioned in one direction and the other. And he tethers the whole roof, and it can be built as an independent piece. Why is it so complex? Juan Calvo has said about this roof, about this project, that it is the most difficult one with which he has worked in his whole life. And he has built very long buildings. You don't know half of it. Why? Because, first of all, this requires impeccable execution. Obviously, for this house, there was a lot of money, and we thought that it was better to use it with technology and construction and not so much to marble and other materials that we're not interested in. We have metal sheets and nude concrete, bare concrete, and ceramic in this house with simple finishing materials, but the technology in construction, domotics, and utilities that are actually beyond normal. It is very complicated because this shell has to be built, supported on something, because we're not going to lift it with jacks because it could break. So we have to build it up there. We cannot do it like Mies with a new gallery, or as we done other times, lifting the structure. The only way is to lift it on a set of pillars. Well, we chose 8 eccentric pillars that have to be eccentric. And why do they have to be eccentric? Because they cannot support the sheet on top, because otherwise there would be a point of conflict between the roof and the facade. So we had to break the pillar 3 or 4 times. It was not a final structure, it was a transient structure. You can see the formwork for the shell here, Xavi following the whole process. The sections, which are fairly cryptic, I would say. I don't think they explain a great deal. The construction itself is more telling. You can see the sheaths here and how they are connected, how it's built. And at the end, this is what we try to do, something that flies over the ground and that it's practically built. Well, the whole house is spatially one single space in which light, in which the relationship with the garden, with the old oaks. When I talk about light, I will talk about that in another class. It all makes sense. But for that sense, for that significance, we needed to build something which was according to that significance, something that provided interior clarity and transparency. We have 2, 3, 4, 5, 6 patios and 2 more that you cannot see. And we have a sheet, a floating sheet, and beneath that a house. It's like a cinema vision of a constructed space. And I finish saying something about location. It is important. It's important to look at it. Once it is unveiled, once it is revealed, the project has a face. It has a face. And I wanted, well, actually, I wanted to tell you something. The other day, I had to excuse myself because I couldn't come to the presentation of the course, and I stayed home because I had a fever. But the other professors have told me that they are all very happy, that they are very satisfied with the result and with your work. And I think that we have to thank you for that. Obviously, you are all working to become good professionals, so you also are doing yourselves a favor. But what I've said in other courses, that you are here in the third year, and in the middle of, it's a very important year for you. You are going to decide what you do here. You're going to become an architect. Are you not to become an architect? Sometimes I say when we begin the course that in 2 years' time, 2.5, 3 years' time, depending on how quick you are, you will finish your studies and you will be architects. Well, I don't know if you will be. You all will all have your diploma, but I don't know how many of you will be architects. And that's something that you have to decide on now. And this is very important because one thing is to have this piece of paper, another thing is to be an architect. So looking at location is very important. Why? Because you already had your ideas working in the dark, and with these ideas will then enter a dialogue with a placement. Do they work? Don't they work? What do you have to change? And you will see how intuitive you have been in the things that you will have seen today. So I encourage you to keep on working and work even harder, please. Thank you very much.